Hi all, welcome to my channel, TheRelevanceLab. So today we will look at how LLMs work. Look at these two statements. I'm sure you would also have come across something similar where it says the LLM has been trained on so many billion tokens, has X number of layers, so many billion parameters or trillion parameters. But what does all of this actually mean? So let's break it down and understand. So let's look at the first one, which is tokens. And here it says it's trained on 300 billion tokens. GPT-3 has been trained on 300 billion tokens. So what does this even mean? So as I told you, tokens are words, or kind of. So in one of my last videos, I had shown you how words are broken down into tokens and processed, right? So when we say 300 billion tokens, it's basically a huge amount of data. It could be like terabytes or petabytes of text data. So now what OpenAI would have done or has done is basically it has crawled all of the internet, right? All your blog posts, all your books, articles, etc. Whatever OpenAI could get its hands on, text data, tokenized it, meaning turning it into tokens, and trained the LLM on it. So when we say 300 billion tokens, so basically it's the size of the text data the LLM was trained on. Got it? Cool. So now let's look at the other two things, keywords, which are 175 billion parameters and 96 layers. To understand these parameters and layers, let me deviate a bit and focus on your brain. Yes, you heard it right, your brain. Okay, hold on. I know what you are thinking. You are probably like, what my brain got to do with LLMs? Trust me, it's very relevant because LLMs are a neural network which has some similarities to your brain. Now, let's imagine an example where you have kept your car keys somewhere other than the usual place or misplaced it somewhere, and you're thinking hard and struggling to figure it out that where did you keep your car key? So what happens in your brain when you are thinking that? So these are a bunch of neurons in your brain, okay, or the cells in your brain which takes in and transmits information, right? And there are lots and lots of this in your brain, like millions of this, trillions of this, right? So when you start thinking, where did I keep my car key? What happens is it sends an electrical signal to one of these neurons. This gets fired or activated because it meets a certain energy threshold, and then it sends the signal to the next set of neurons which it is connected to. And as you can see, this cycle happens and it always keeps happening all the time. And what will happen is, after one point of time, you will see that this neuron triggers that information where you had kept your triggering that information to your brain. So you'll say, hey, got it. It's in the kitchen next to the coffee maker, right? And you are happy. So as you can see, your brain is happy now. Earlier it was struggling to figure it out. So you received that information. So at this point of time, I'm pretty sure you are all still thinking this is all fine, but what does this got to do with LLM? And right now, it will all make sense because, and how it all connects, because this is how the inside of an LLM looks like. So these are all neurons, bunch of neurons which are connected to each other. So as you can see, it's very similar to the neurons which we were looking at in your brains, right? So remember earlier I told you that LLMs are a neural network. So that means it is nothing but a network of neurons. So as you can see, all these are connected. And if you really look at it, they are sort of divided into layers, or they are structured. So if you can see here, it's the input layer, is layer 1, layer 2, layer 3, and then the output layer. So again, if you recollect the sentence or the statement, GPT-3 has 96 layers. So here you can see we just have 5 layers, right? 1, 2, 3, 4, 5. But GPT-3 has 96 layers. So you can imagine how much more neurons or how much more data it would be transmitting, right? So now we saw tokens and layer. But what about parameters? So we saw that GPT-3 has around 175 billion parameters. Llama 3 has 405 billion parameters. So what does this mean? So parameters are nothing but it's sort of an umbrella term where it consists of a lot of different things, and it basically refers to the calculations that are going on inside this LLM. So there are things like weights, biases, then learning rate, temperature, and so many other hyperparameters which are considered when the calculation is going on within these LLMs to predict the net total. Okay, so for this video, I'll take just two parameters like weights and biases just to give you an example. Now, say for example, you are taking starting with an input number of 500 in the input layer. Okay, and then these lines, all these black lines are called weights, and each neuron has some bias. So again, for the sake of simplicity, these are all considered as having some numerical numbers or calculations. Okay, so now if you take this input as 500, and when it is multiplied by a weight of zero point 0.7, that gives you a number of 350. And then when it reaches this neuron, so this neuron adds a bias of plus 30. So that is equal to 380. Now we had 350 plus 30, that is 380. Now say for example, this neuron's threshold was 300. Okay, so to figure to get triggered. So then it will be sending the electrical signals or to the next connected neurons. So all these neurons in layer 2. Now continue this example. Now say for example, this has a weight of zero point 0.2. So we had 380. 380 into 0.2 is I think 76. So that will be added to this, that will go to this neuron, and it will add another bias of plus 6. So that will be 82. Now, if this neuron has a threshold of say 100, then it might not fire. Okay, but if it has a threshold of say 80, then it will trigger again to all the send signals and trigger it to all the other neurons in the next layer, and so on and so forth, until you will get some output number here. So now how does this really connect with our ChatGPT or Claude or Gemini? So let's take a simple example. Now, say for example, you're typing into ChatGPT as hello, how are? Okay. Now, this is the input layer. So what happens is that so all those calculations of weights and biases and things of that nature will be the calculation will be going on within this LLM. And finally, if you see, the output layer will give you the next predicting token, that is U, right? Now, what will happen is, since this is LLMs are auto-regressive, meaning it will take this U back to the input layer. So, okay, so what happens is this will take this token U back to the input layer here again, and then it will be hello, how are you? And again, all that calculation, weights, biases, learning rate, all these things happen. And again, it could predict the next token, which could be a question mark, or it could be like, how are you doing? Again, right? So doing again, it will take that doing today. So right, like that, it might keep on doing the calculations. So now this is where it is. This is how the inside of the LLM works. Now, although we from a ChatGPT perspective or from a human angle perspective, we only see this input layer, right? So we just give the input and we get the output in ChatGPT. But how does it determine all these things within the inside of this thing? We don't see that as a humans, right? So that is why it is called a hidden layer. In fact, there is a study or a research going on that to understand how these LLMs are actually able to predict the next token so accurately. And that study is called as mechanistic interpretability. So if you Google this term about mechanistic interpretability, you'll be able to see some articles and videos and understand more about it. Cool. So now going forward, if you see some statements like these, or if somebody talks about tokens, parameters, layers, you actually are now can are able to understand what that means or what they are referring to, and can understand how these LLMs are working behind the scenes. So you are better than 99% of the people out there who just use ChatGPT or Claude blindly. So thanks for watching this video. Hope you found it useful. So if you found this content useful, kindly like, share, and subscribe to the channel. Stay relevant, stay ahead.